Now let us try to understand functions and their domain and range when algebraic equations are given to us. So in this example, we will consider the relations given as an algebraic equation. So we have three of them here. We need to state their domain and range and answer if each relation is a function or not. Relations given to us are x plus y equals to 10, xy equals to 10, x squared plus y squared equals to 10. Now, let us assume that x is the independent variable and y is the dependent variable. Now we'll rearrange so that we can find what y is, that is to say, how is the independent variable and dependent variable related. So real relation is that y is equals to, we can take x on this side, we say minus x plus 10. So that is the relation. Well, we know it is a straight line. We can sketch this function here. So I'll make a small rough sketch. Now minus x means slope of 1, minus 1, and y-intercept of 10. So it'll be a kind of line like this. Right. So that's what we have as a straight line where the y-intercept is 10. If I put x as 0, then y value is 10. And if I put y as 0 here, then we get x as 10. So, well, this point is also 10. That gives us a slope of minus 1. Now for this relation, we see that it passes the vertical line test. For every value of x, we have a unique value of y. So it is definitely a function. Now what is its domain and range? Well, the domain is all the x values, right? X the independent variable, y the dependent variable. Domain can be written as x belongs to real numbers. As far as range is concerned, that is also all real numbers. So we can write y belongs to real numbers. So that is our domain range. And we saw that this is indeed a function, right? So we'll write this as a function. Since this passes the vertical line test, every value element in the domain is associated with a unique element in the range. Now let's consider the next relation. xy equals to 10, we can write this as y equals to 10 over x. So it's kind of a reciprocal function, right? So we can sketch this function. Let me sketch it here. So reciprocal function is kind of like this. So if you take different values of x, if the x value is 1, y will be 10 in this case, right? Okay, so it will be like, if x value is very large, then the y value will be approaching 0. If x is approaching 0, then 10 over 0 will be infinite, or less, very, very close to 0 will give us a high value. If x is negative, then we'll get y as a negative value. So that is how this relation can be graphed. Now from here we can see that x can have all the values but not 0, and therefore the domain has a restriction. So we say domain of this function is that x belongs to real numbers but x is not equal to 0. Let's write down the range. As far as range is concerned, we know the function approaches 0 but it is never 0, right? And therefore range is y belongs to real numbers but y is not equal to 0. So that is the domain and range for this relation, and this relation is a function, right? So we'll write this as function since it passes vertical line test. Now let us consider the third relation, which is x squared plus y squared equals to 10. If I isolate y, I get y squared equals to 10 minus x squared, and I can write y as equals to plus minus square root of 10 minus x squared, correct? So whenever you do square root, you have to write plus and minus. Well, it clearly indicates that for many values of x, we may have two values of y, plus and minus. Therefore, it is not a function, right? So, since we have two values, right, for a given x value, it is not a function. Now let's consider its domain and range. Well, x squared plus y squared equals to 10 is what? It is a circle, right? It is a circle with radius of square root of 10, right? X squared plus y squared equals to r squared is equation of a circle. So this is square root of 10. So this side is minus and that side is this plus, right? So that is what the value is, square root of 10. And therefore, from here we can write that domain is all x values. We say x belongs to real numbers, but we can say x belongs to real numbers so that x is greater than equal to minus square root of 10 and less than equals to square root of 10. That is how we can write what domain is, right? Everything in between, including square root of 10, plus and minus. As far as range is concerned, range is also y belongs to real numbers so that y is between minus square root of 10 and plus square root of 10. Okay, so that is how we can write domain and range for this relation. Well, as you can see, if I draw a vertical line, it crosses at 2 points. That means this particular x value will have 2 points. Similarly, other vertical lines will cross at 2 points. And that is the reason why this is not a function. It is just a relation. Okay, so that's very important to understand. Now, as far as the notation goes, at times we can write domain and range for this function in the set. This is in the set form. We can also write this as domain x equals to, within brackets, minus square root 10 comma plus square root 10. That means including minus and plus square root 10 and all the values in between. Similarly, we can write range also in this form. So that is another way of writing domain and range. Well, if these brackets are square brackets, then the value plus minus square root 10 is included. But if this is not a square bracket, but it's a normal coordinate, parenthesis, then it is not included. Okay, so we call them kind of open brackets. So that is how we can, analyze equations and figure out whether they are functions or not, and also find their domain and range. I hope that makes sense. So continue and look into more algebraic equations and see how we can find whether they are functions or not and what their domain and range should be. Thank you and all the best.